Good morning, everybody. This is Rebecca Best talking. I think we'll get started. I hope everybody's doing well. Thank you for joining us this morning for this presentation on CET part numbers. I hope I don't bore you to death, as it might get a little repetitive. However, understanding the methodology behind our part numbers will be helpful for staff who enter POs, request quotes, create sales orders, or maintain product information. In this presentation, we are going to learn about the structure of our product numbers and how they are created. And I will be using several of our popular products as examples. In addition, at the end of the presentation, I'm going to show you where to find the serial numbers of our products, what information is included in that number, and why serial numbers are important. If you have any questions during the presentation, please type them in the comments, and Mirza and I will answer them at the end of the presentation. Okay, so let's start with the three components that make up our part numbers. The first component is the product brand, such as LPTA or LPTM, SCC, or C-gas. Each product brand offers different features and functionality. The second is the target gas code or codes, like TCO, NO2, O2, or NH3. This code tells you what gas sensor is inside the device. The third is a factory installed option code or codes that represent optional features like splash guard or heater or analog inputs or strobes. If we take an item from each component, we can create a simple part number example. For an LPT transmitter with a carbon monoxide sensor and a splash guard, the part number is LPT TCO-S. Now, before I continue, I want to point out some inconsistencies that I'm sure you would have noticed had I carried on. Most of the time, the target gas codes are the same as the chemical formula of the gas, such as O2 is oxygen, PH3 is phosphine, H2S is hydrogen sulfide, and in the case of the C-gas product line, nitrogen dioxide is simply NO2. However, sometimes the target gas code has been slightly altered. Take CO, for example. Some products use TCO and others have an A or a B added. And look at NO2. It has a few anomalies as well. So why is this? Many manufacturers make CO or NO2 sensors, and each sensor can have different technical specifications such as size, range, unit of measure, physical attributes that affects how it connects to the board, lifespan, and more. So assigning different codes for the same gas helps us know which sensor is used in the product. The different codes also help us answer technical support calls more quickly and ensure the correct replacement parts are quoted or sold. Here are a few more examples of where we have included additional information in the part number. In this example, the S before the refrigerant gas means that is a solid state refrigerant sensor. The C before C3H8 indicates that the sensor type is catalytic, and the -100 means that the sensor range is 0 to 100% LEL. The 5K on the C-gas CO2 part number tells us that this CO2 sensor range is 0 to 5,000 ppm. So let's take a look at some more products and the structure of their part numbers. In our first example, we have the LPT low power transmitter. It is a single channel gas detector that can be configured with one of the gas sensors listed here. It can also have an optional splash guard installed, which is common if it is used in a wet environment or in an area that is frequently sprayed or washed down. So if we have an LPT with a CO sensor, the part number would be LPT TCO. With an NO2 sensor, it would be LPT END. With a chlorine sensor, it would be LPT-Cl2. Ammonia, LPT-NH3. Oxygen, LPT-O2. And ozone, LPT-O3. If the part number had a -S at the end of it, that would mean that the unit had a splash guard, like this. The next product we will look at is the LPTA analog transmitter. This is also a single channel gas detector, but the LPTA has many internal sensors and can also be configured with an internal sensor or a remote combustible gas sensor. There are also more options available, such as a splash guard and an internal heater for cold environment applications. So if we have an LPTA with an internal CO sensor, the part number would be LPTA-COA. An LPTA with an internal nitrogen dioxide sensor would be an LPTA-NO2B. If the unit needed a splash guard, that would be indicated with a -S. If both a heater and a splash guard were required, the option codes would be added in alphabetical order like this. An LPTA without an internal sensor does not have a target gas code in its part number. Instead, after the product brand code, there is a -R, which means the LPTA will be paired with a remote sensor. The ESHA is a remote device with a combustible methane, propane, or hydrogen gas sensor. Connecting a remote sensor to the LPTA allows the remote sensor to be mounted where it will be able to detect the target gas. For example, methane and hydrogen are both lighter than air and will float up towards the ceiling, so the ESHA should be mounted on the ceiling. Propane is heavier than air and will fall towards the ground and pool in low-lying areas, so the ESHA should be mounted close to the floor. With a remote sensor detecting the gas, the LPTA can be mounted in viewing height, so the gas reading sent to it from the ESHA can be seen on the display. For an ESHA with a methane sensor, the part number is ESHA CCH4-100. The C before the CH4 indicates that the sensor type is catalytic, and the dash at the end means the sensor range is 0 to 100% LEL. The part numbers for an ESHA with propane or hydrogen sensor follow the same structure. When an order is placed for a transmitter and a remote sensor, I went backwards. The two devices are added as separate line items. Our production team configures the two devices to work together. Now let's take a look at the LPTP digital transmitter. This product is very popular in parking garage applications. It can be configured with one internal sensor, two internal sensors, or a remote sensor can be added to either of those configurations, equaling 3 gas sensors in total. It is also available with an optional splash guard. The part number, LPT-TCO, is an LPTP transmitter with an internal CO sensor. LPTP-NO2B is an LPTP with an internal nitrogen dioxide sensor. If the LPTP has 2 internal sensors, then both target gas codes are included in the part number like this. An S at the end would indicate the unit has a splash guard installed. As I mentioned earlier, an LPTP with 1 internal sensor or an LPTP with 2 internal sensors can also have a remote sensor, which means they can be connected to an ESHA. Taking what we learned about the LPTA and ESHA part numbers, we apply the same methodology and add an R at the end. The R indicates that the LPTP also has a remote sensor. Moving on to the carbon dioxide C-gas detectors. This gas detector is available with 4 to 20 milliamp analog output or with digital Modbus BACnet output. The first part of the part number indicates which is which. C-gas A, the A signifies analog, and C-gas D, the D stands for digital. This is followed by the target gas code, CO2. Because we have two types of CO2 sensors, more information is included in the part number. 5K indicates that the CO2 sensor range and units of measure is 0 to 5,000 ppm. And 5% indicates that the sensor range and units of measure is 0 to 5% volume. The digital model is available with an optional RH and temperature sensor, which is indicated by the code RHT at the end of the part number. Continuing with the C-gas D, which has many internal gas sensor choices, it also has plug-and-play smart technology, which means when the sensor needs to be replaced, it is as simple as removing the expired smart sensor board and plugging in a new smart sensor board, which comes pre-calibrated. The C-gas D can be configured with one internal sensor, two internal sensors, or one internal sensor and one remote combustible gas sensor. Examples of one internal gas sensor part numbers are C-gas D, CO, indicating an internal carbon monoxide sensor, C-gas D, NO2, with an internal nitrogen dioxide sensor, C-gas D, O3, has an internal ozone sensor, and C-gas D, SR410A, has an internal solid-state refrigerant sensor. Examples of part numbers for two internal sensors are C-gas D, CO, NO2, C-gas D, CO, H2S, which is an internal carbon monoxide sensor and an internal hydrogen sulfide sensor, or C-gas H2S-SO2, which has an internal hydrogen sulfide sensor and a sulfur dioxide sensor. The C-gas D has the following options: an RH and temperature sensor, which we use the option code RHT, a relay, which is an option code RLY, and a splash guard, which I'm all sure we know are very familiar with now. Here are examples of part numbers with the options added to them: a splash guard on a single channel CO detector, a relay on a single channel CO detector, and an RH and temperature sensor on a dual channel CO and NO2 detector. And lastly, the only C-gas D model that can have both the RHT and RLY options, that has an internal CO sensor, and we're adding a splash guard just to show that option as well. For a C-gas D that has one internal sensor and one remote sensor, it follows the same methodology as the other products we have looked at. After the internal target gas code is an R to indicate that the C-gas D will be connected to a remote sensor. And the required ESHA, which in this case has a methane sensor, is included on a separate line. Our two self-contained controllers, the SCC and the DCC, are very similar products. The DCC has a few additional features, such as the display, two analog outputs, and more gas sensor options. However, the structure of the part numbers is the same, so I'm going to use the SCC as the example. The SCC can be configured with one internal sensor, or one remote sensor, or one of each, or two internal sensors. It can also come with a splash guard. We have included a letter after the product brand that indicates the type of configuration. A is for one internal sensor, B is for one remote sensor, which means the SCC does not have an internal sensor, D is for one internal and one remote sensor, and E is for two internal sensors. Other than that addition, the part number structure is the same as the other products we have gone through. So the part number for an internal CO sensor is an SCCA TCO. And for nitrogen dioxide, it's SCCA NO2B. One remote sensor means that the SCC doesn't have an internal sensor. SCCB is the code that represents one remote sensor. And there is no target gas code, and an R is added to indicate that an ESHA remote sensor is added as a separate line item. For two internal sensors, both target gas codes are represented in the part number. And if a splash guard is required, there's an S added at the end. One internal sensor and one remote sensor, the SCCD part number includes the target gas, in this case CO, and the R is added to indicate that there is a remote sensor, and the ESHA is added as a separate line item. Now here is where we add something new. The SCC can be connected to an LPT TCO or an LPT END transmitter. This allows for a self-contained system with two sensors in different places. For example, one CO sensor inside the SCC and another CO sensor in an LPT mounted in another location. In the part number, the same way a -R represents an ESHA remote sensor, a -RT represents a remote transmitter. Shown here is an SCC with no internal sensor. The RT indicates there is a remote transmitter, which in this example is an LPT with a CO sensor. Similarly, if the SCC has an internal sensor, the target gas code is included in the part number, and adding the RT means there's a remote transmitter in the configuration. And in this case, there's an LPT NO2 transmitter. The last product example I will be using to illustrate part numbers is the FCS Flexible Control System. This is our full system controller, and it can handle up to 128 gas channels. We also offer the FCS with up to 8 channels for smaller applications. To distinguish between the two systems when looking at their part numbers, the product brand code for the 128 channel system is FCS. And for the 8-channel system, it is FCS-8. Next comes the letter that indicates the type of output the device has back to a building automation system or another control panel. The choices are M for Modbus or B for BACnet. The same follows suit for the FCS-8. Some of the features that come standard with the FCS control system are 4 dry contact relays, digital output, Modbus or BACnet, data logging, enhanced logic control, 2 horn strobe outputs, and an audible alarm. The FCS is designed out of the box to connect to digital transmitters via Modbus communication. If analog inputs or outputs are required, these options, along with many more, can be added to the FCS at the time of purchase. These are the available option codes for the FCS and the FCS-8. AO indicates 4 analog outputs. 2AO indicates 8 analog outputs. AI, 4 analog inputs. 2AI, 8 analog inputs. AIAO, 4 analog inputs and 4 analog outputs. DL is a door lock that comes with 2 keys. IH is an internal heater, which is a heater inside the enclosure. L indicates a top-mounted strobe. FW is a manual shut-off switch. And WA is a watertight alarm that's mounted on the door. As an example part number, here is an FCS-M with a door lock, top-mounted strobe, and a manual shut-off switch. The part number is FCS-M-DL-L-SW. Here are a couple more examples. FCS-M-AO is the part number of an FCS Modbus output controller with 4 analog outputs. FCS-8M-2AI is an 8-channel FCS Modbus output controller with 8 analog inputs, and it is ready to be connected to 8 analog transmitters. And the FCS-B-L-SW-WA is an FCS BACnet output controller that has a top-mounted strobe, manual shutoff switch, and a watertight alarm. I want to point out that a lot of the time you can add options upon options. However, these options are exclusive of each other, so only one or none of these options can be installed on the FCS. Now, just before we wrap up here, I'd like to tell you a bit about our product serial numbers. We put a serial number barcode label on every enclosure. Here's an example for an FCS. I've broken the serial number up into its parts. First is FCS-B. This is the product line. In this example, it is an FCS BACnet controller. Second is the year and month it was manufactured. In this case, it was September 2016. The letter represents the revision of the circuit board. In this example, this FCS was built with Rev B board. And the last 5 digits is the sequential number the unit was given during production. So in this case, this was the second unit made in September 2016. The serial number label is placed on the right-hand side of the enclosure on the base just under the lip that holds the screw to keep the enclosures closed. The serial number tells us a lot of information about the device, such as the age of the unit, whether it's still under warranty, what board revision the unit was built with, how old the sensor is, and for some products like the LPTA, what type of sensor is installed. The reason for including all this information in the serial number is so when someone calls in for technical support or wants to order a replacement sensor or replacement part, if we are given the serial number of the device, we can make sure we are making accurate and efficient recommendations for that specific product. As a final note, I just want to make mention that for ESHA remote sensors, we make the serial number for the transmitter or self-contained controller that it's being connected to and the ESHA serial number the same. If the ESHA is connected to a device that has a different serial number, the system won't work. So that's everything for CET part numbers and serial numbers. I hope I was able to shed some light on how to interpret our part numbers. I didn't cover all our products, but if you apply the same methodology, it should work for the majority of them.